Section 7.1, Introduction to Decimals. Decimal numbers are any number that can be represented using place value and powers of 10. In this number below, 1,234, we've already talked about these types of numbers and their place value when we talked about whole numbers. One of the things we did was write it in expanded place value, and so we had to use the powers of 10. So the ones place was 10 to the 0. The tens place was 10 to the first, hundreds was 10 squared, thousands was 10 cubed, and so on. It would go up by a power each time. When we go on the other side of the decimal, the first place is called the tenth place. The 1/10th place. Notice that has 1 0, and we're in the first decimal place. So it's going to end up being 10 to the negative 1. Hundredths is the second decimal place. 1 over 100. 100 has 2 zeros. It's in the second place. It's going to be to the negative 2. And hopefully you start to see a pattern. Next will be to the negative 3, and then to the negative 4. And if we kept going out, we'd have more 10 to the negative 5th, 10 to the negative 6th, and so on. So expanded place value was a way of writing numbers to show the value of each digit. And we did this before with whole numbers. We're going to do it with this number, 205.365. So first, you're going to start with the 2. Since it's in the hundreds place, it's going to be 2 times 10 squared, plus the 5 is in the ones place. So we usually just left that as a 5, because if 5 times 10 to the 0, anything to the 0 is 1, and 5 times 1 is 5. Okay, then we start going to the numbers in the decimal side. So 3 is in the first decimal place, so it's going to be to the negative 1. 6 is in the second decimal place, to the negative 2. And 5 is in the third decimal place, so times 10 to the negative 3. Going the other direction, we're going to write this as a decimal. I like to find where the whole number is first, and that's where my decimal is going to be. So this whole number is in the ones place. This right here, 10 squared, imagine that's 1 times 10 squared, which means 1 is in the hundreds place. 10 squared is 100. The 3 is in the wherever the 10 to the 5th is. Well, 10 to the 5th is the 100,000th place, or 100,000th place. I'm going to put it over there. Then going to the right of the decimal, 2 is in the first decimal place, and 5 is in the third decimal place. When reading a decimal number, the decimal is read as the word and. Now, many people will say 232 as 232, but it's not quite correct. From now on, I want you to only use the and if there is a decimal place. So 152.34, the way you write this out in words is you first write 152 just like you would say it. Then we have the decimals, we'll have and. Read 34 as a number, so that would be 34. And then put the last decimal place. This is in the hundredths place, so this will be hundredths. So 152 and 34 hundredths. The next one doesn't have a whole number place, so we'll just start with, this is a 12. And then we have 1, 2, 3, 4, 5 decimal places. So 1 followed by 5 zeros. 2, 3. And you can count those, but this would be 100,000. Notice I put the dash here. You do need the hyphen in this case because 100 thousandths needs to show that it goes together. Okay, that is the place value. If you write 1200 thousandths without the decimal, it will mean something else. And I will show that in just a minute. Next one, 2,027 thousandths. We're going to go the opposite direction and write this as a decimal. So we start with the 2,000 and is decimal, and then it's 27 thousandths. So thousand, think of 1,000 has 3 zeros. So we're going to have 3 spots to the right, and you're going to write 27 as far to the right as possible, and then fill in zeros. The next two, one has a hyphen and one does not, so I wanted you to see the difference. 400,000, okay, so a decimal. This one's 100,000, which has 5 zeros. So we're going to have 5 decimal places. And 4 goes as far to the right as possible, and we will fill in zeros. The next one without a hyphen, that means the 100 goes with the 4, and that's 400. And the place value is 1,000, which only has 3 decimal places. And then you write the number 400 as far to the right as possible. And so we get 2 very different numbers. Next, terminating decimals. These are decimals that can only be written with a finite number of places to the right of the decimal point, meaning they stop forever. So 10.22, 0.356, 1/2. The reason I have 1/2 here is because that's the same as 0.5. We have a theorem that says a rational number in simplest forms can be written as a terminating decimal if and only if its prime factorization of the denominator contains no primes other than 2 and 5. Okay, so first thing you need to notice is that it said it had to be in simplest form. So make sure you're in simplest form when you're trying to do these problems. Then you're going to look at the denominator and find its prime factorization. And if it's only made up of 2's or 5's, it's terminating. If it is not, then it is not terminating. So let's look at some examples. 7/8 is in simplest form. We're going to look at 8, 2 times 4. That's a 2. 4 is 2 times 2. So this only is made up of 2's, which it said 2 or 5. So then, yes, this is terminating. The next one is also in lowest terms. Let's see, we could do 25 times 5. 5 is prime. This would be 5 and 5. So that's only made up of 5. So yes, this one is terminating. The next one, 2 over 30, is not in simplest terms. So we first have to simplify it. And this will be 3 times 5, which are both primes. But it's not made up of only 2 or 5, so this one would be no, it does not terminate. The next one, 21 over 28, also reduces. 7 goes into both, leaving 3/4. 4 is 2 and 2, so this one would also be yes. Now make sure that you do reduce, because in this case, if you had left it how it was, 28 would be 7 times 4, 4 would be 2 times 2, and here you would have said no and had an incorrect answer. Converting from fractions to decimals. Okay? To convert from a fraction to a decimal, all we do is divide the numerator by the denominator. So where possible, we're going to write each fraction in the previous example as a terminating decimal. So in your calculator, you write 7 divided by 8, and you'll come up with 0.875. On these, I would only be looking for the answer. For B, we said it was terminating, so you do 11 divided by 125, and you get 0.088. C was not terminating, so we won't do that one. You could check it and see that it does go on forever. And then D, you can either put in 21 over 28, or you could put in 3/4. Either way, you're going to come up with 0.75. Going the other direction, converting decimals to fractions, you're going to write down all the digits in the number, dropping the decimal point, and then put it over a denominator of 10 to the power of the last place value. Now, when you're doing these, I want to see your original fraction. So on this one, I do 2832. The last is 100th place, so this is going to be 100 over 100. I want to see this because I want to see that you understand the place value there. Then you can use your calculator to 2832 divided by 100. Use your math, enter to get it to change it back to a fraction so that it is reduced. This would reduce to 708 over 25. The next one, the number will be 356. It's got 3 decimal places, so it'll be over 1,000, which has 3 zeros. Remember, again, I want to see that fraction, put that into your calculator, and reduce it to 89 over 250. The last one, the negative, just keep it in the front. It'd be over 10 because it's in 1 decimal place. If you put this into your calculator, you'll find it does not reduce. Ordering terminating decimals. When we want to put numbers in order, what we're going to do is line up the numbers by place value, and we'll put zeros at the end if necessary to keep the numbers the same length. We're going to start at the left and find the first place value where the digits are different, and then we'll compare the digits after that. Pay attention to your directions, whether it says to put them from least to greatest or greatest to least, because it does ask both. So I'm going to follow these steps. So I've got 23.351, 23.3502, 23.3515, 23.352. Now I'm going to fill in a 0 here and here so that they are the same length. Then I'm going to look at my digits. I have 2, 3, decimal, 3, 5, and then they start to become different. So I want least to greatest, so I'm going to look at the one that's the smallest here. Think of this as 10, 2, 15, and 20. So the smallest would be 2. So it would be 23.3502. That was that one. Mark it off there. The next one will be 10. Now when I write it in my list, I want it to look the same way it did originally. So it'll be 23.351. Next would be 15, the third one. So 23.3515. And then that leaves us with the last one, 23.352. Remember, write it how it was originally. Now, if you have negative numbers, just be careful because negative numbers go in the opposite direction. So if it asks least to greatest, you can look at the absolute value of the number and do greatest to least. So just be very careful of that. There are a couple of problems on the worksheet, but I've put that with the end of 7.2 because I usually teach those in the same day. This concludes the notes for 7.1. If you have any questions, feel free to use the Ask My Instructor button.